I just want to talk about real quick is the fundamental counting principle, which I think you have an idea on. You just might not know what it's called. But if you were to roll a die, and of course I'm going to say a regular six-sided fair die, okay? What are your choices? Or how many choices are there for you to roll? You could roll a 1, 2, 3, 4, 5, 6. There's 6 different outcomes that are possible. And in the last example, then we flipped a coin. How many different possibilities are there? How many different outcomes are there? When you flip a coin, you can either get a heads or a tails. So there's 2 different outcomes. So something I forgot to add was that your total amount of outcomes is going to be, if you multiply them, 12 possible outcomes when you put these together, if you were to do both of them. So I don't know if we talked about it, but if you notice, in the end, we were getting 1/12 for each one of those lines of the probability tree diagram. And that 12 is also, you can figure it out without doing a tree diagram, because 6 outcomes for a die, 2 outcomes for a coin, when you multiply them, there'll be 12 total outcomes. So let's move on to conditional probability. And this is one of the ones that might be kind of tricky. So I assume you might need to watch this video more than once, or you might need to pause it, and you'll need a calculator out as well to help you with it. The probability we assign to an event if we know something else has occurred already. So I'll give you the notation. It will look like this. P of B line A. Okay, it won't be like a U or an upside down U. Okay, and what this means is the probability of B given that A occurred. So it's written like this. A has happened already, okay? That one would be written last. So based on A happening, what's the probability of B now happening? So I put together a table, and I think it's the easiest way to explain it with something like this so that we can look through the numbers. So I'm just going to go through a couple easier ones, like find the probability that you pick somebody who's over the age of 51. Okay? So over 51, and it has its own column all the way across, or its own row. There is a total of, if you see in the end, 3,200 people that are in this whole table. Now, over 51, there's people who like chocolate ice cream, like vanilla, like strawberry. I don't care about that. I just want to know how many people are over 51. So you have to actually total up how many are in that column. And there's a bunch, or in that row. So when I did it in my calculator, I got 794. So the probability of this occurring, there are 794 people that are over 51 out of a total of 3,200. And I can reduce this, and I can change this to a decimal. I think when I change this to a decimal, 0.248, something like that. Or 24.8%. Probabilities can be written as fractions, decimals, or in a percentage. All of them would be acceptable. Let's try the next one that I want you to look at. Probability that someone likes vanilla. Now there's 3,200 people possible. When I look down the people who like vanilla, I'm not caring about any of the age groups. I just want to know if they like vanilla. So for this one, I'm going to be adding up 366, 424, and 72. And I'm going to work downward from the table. 862. And you could reduce it. You could also divide. When I divide it, I get a probability of about 0.269 or 26.9%. That's what all that means. Let's try something where they are under 30 or they like the chocolate ice cream. So under 30 and likes chocolate, out of everybody, there's 3,200 people. Under 30 and likes chocolate, I don't want to mark my table, but look where those intersect, and there's 604 people in that section. But this is the or. So this means everybody under 30. 604, 366, 322, plus everybody who likes chocolate. Now I've already counted the 604. Those are the people who like chocolate, but there's 404 more, and then 336 more who like chocolate. And technically, I'm adding all of these probabilities up, of all these things, and getting a total of a lot of people, 2,032 out of 3,200. At about 63.5% of the people either are under 40 or under 30, or they like chocolate ice cream. Part D is, we're going to use an and. Probability of being over 51 and liking vanilla. Now the trick with this means it's got to be where both happen. Not the joining of everything. It's not either or. I want to be over 51 and like vanilla. Those are the two things that I need to happen. So I want to look only where those intersect, and that's 72 out of still the total amount of people. This is a very small amount. Around 0.0225 or around only 2.25%. It's a small amount in comparison to the study. Now E is going to use this conditional probability. Okay? And I'm going to write it out as well. What is the probability you choose someone who likes strawberry ice cream, given that you selected someone under 30. So if you look up at the top, there was the notation P, B, A, right? The given that A occurred, the given goes here, that something occurred, and this is the one you're trying to find the probability of. So when I write this in notation, it would be, I'm trying to find the probability of choosing someone who likes strawberry, given that someone is under 30. Now, when you do something like this, you're not going to use the total anymore as 3,200. You're going to be using the total now for people that are under 30. So this is where you're going to get your probability of under 30. Or my total number of people under 30. When I add up everybody that's under 30, there is 604, 366, 322. Add those together, and I'm getting 1,292. So technically, I'm going to have 1,292 in my denominator. Because I'm not picking from everybody. I'm only picking from selecting people who are under 30. That's what I'm given to pick from. Now I want the people who picked strawberry. If I look at the people who picked strawberry, I also want people who selected strawberry, but only those people who were also under 30. I don't want anybody else. So strawberry and under 30 is 322. And I can reduce this and write it as a fraction or as a decimal, but I want you to get in the habit of looking at something like that. Let's try it a different way. What's the probability you choose someone who is under 30, given that you selected someone who likes strawberry. So notice we're going to do it the opposite way. The bar in the middle, okay? The probability is the one you want to find. So the probability of someone who's under 30. And you're only going to pick from people who like strawberry. So you need all the people who like strawberry underneath. If I total up all the people who like strawberry, I'm going to get, for strawberry, 322, 286, 386. If I add all those people together, 994. Now I want my people who are under 30, but not just all of them. I want the people who are under 30 and who like strawberry. So that is only one little column, and that's 322 at the top. So it is a little bit different when you rearrange the order. Notice it's the same type of question, but I was picking from strawberry lovers here, and the one before I was picking from people who were under 30 instead of the total. Last but not least, I want to try just one more because it can be worded a little bit differently. So I'm putting, suppose you randomly choose an individual who's between 30 and 51. What's the probability the person you choose likes chocolate ice cream? So again, when you're trying to do something like this, even though it didn't say those key words of given that, you're limiting the number of people you're picking from. You're choosing from people between 30 and 51. And there's a space for that on the chart. And you want people who like chocolate, who are from that group. The total amount of people between 30 and 51. And if you look at the chart, between 30 and 51, there is 404, 424, and 286. And you should get 1114. Now the people who get chocolate, but also it's chocolate and 30 to 51 is one column only. And that's the 404, the first one. And of course we can reduce this. We can write it as a decimal and as a fraction. But the big idea is that B occurs given A has already occurred. You're basically finding out B and A occurring in the numerator out of A possibilities.